Our solar system is a wondrous place with a single star, our sun, and everything that orbits around it: planets, moons, asteroids, and comets. What do we know about this beautiful solar system we call home? It's part of an even larger cosmos with billions of other solar systems.
Hi, I'm Jim Green, Director of Planetary Science at NASA, and this is Gravity Assist. And with me today is Dr. Sarah Noble. She's a program scientist at NASA headquarters, and she knows everything about our nearest neighbor, the moon. You know, the moon has just been a fabulous object in the sky that, humans from day one have always observed, and we've been studying it up close and personal for now several decades. But what do we really know about how it was formed?
So, our best understanding of how the moon formed is that early in the formation of the solar system, a big planetesimal, something about the size of Mars, crashed into the Earth. And that spewed a lot of material off the Earth, which then came back together to form what we think of today as the moon. So the moon really formed very hot and very violently.
You know, my understanding of that initial part of that theory is as the moon began to coalesce and come together, it actually was pretty close to the Earth.
Yeah, it was much closer than it is today. The moon actually continues to move away from us at a rate of about 4 centimeters a year. So back in those days, yes, the moon was much closer and would have been much bigger and brighter in the sky.
You know, it also affects the Earth in terms of messing with our tides, tugs and pulls. And so at that time, if it was so close to us, the tides must have been enormous.
Yeah, exactly. They would have been much bigger than we see today.
But another thing that it really is exciting about the fact that the moon is slowly moving away is that we live in a wonderful time because of the fact that the moon is just at the right distance that allows us during solar eclipses to pass completely in front of the disk of the sun.
Yeah, it's perfect right now. You know, there will come a day when it no longer will cover up the full scope of the sun and we won't be able to have eclipses anymore.
You know, one of the things about the moon since the Apollo days, when we deployed instruments and stuff, were to really try to understand much more about its structure. What do we know about its structure today?
So the Apollo missions actually left behind seismometers. So for a while, we had a seismic network on the moon, and we measured a lot of moonquakes, the moon equivalent of earthquakes. And we sort of understand there were both shallow moonquakes and deep moonquakes, and that begins to help us understand what the internal structure of the moon is. The moon actually turns out to have a core just like the Earth does.
Do we know if the core was ever liquid?
We don't know, but presumably it was early as it formed, and the heavy elements, the iron and nickel, sort of swam to the bottom and to form the core.
You know, one of the things that we know about our core that's liquid is that it facilitates a current that runs around the Earth, which generates a magnetic field, which gives us a magnetosphere. Is there any indication that happened to the moon too?
So the moon doesn't have a magnetosphere. It does have local areas where there are magnetic fields, probably caused by very large impacts.
You don't think those areas could have been remnant magnetic fields? Who knows?
Who knows?
It's another exciting thing to be studying on the moon. In fact, those remnant fields that are trapped in the crust of the moon really kind of changes the environment that they're protecting. What happens?
That's correct. They form something we call swirls, which are these really cool patterns of light and dark markings in these sort of swirly patterns that we find in particular places on the moon where we have this remnant magnetism.
You know, as the moon started to form, we know, like the Earth, it was probably very volcanic. What do we know about how the moon evolved over that period of time? And could it had an atmosphere like the Earth?
Yeah, this is actually some very exciting research that just came out recently, indicating there were so many volcanoes about 3.5, almost 3.8 billion years ago, that it might have had a temporary atmosphere. Something not like our atmosphere, but more akin to Mars's atmosphere, sort of thin, but enough to have wind even. On the surface of the moon, and that atmosphere would have been sort of very full of volatiles, including water. It's actually, we think, possibly one of the sources of the water at the lunar poles.
That's really cool. So if there was an atmosphere and some sort of circulation, are there indications or are there places on the moon that we could actually go and make measurements that could tell us about that ancient atmosphere?
So there are these permanently shadowed craters at the poles, and we know that they have volatiles in them, including water. We have measurements from space, but we also have in situ measurements. We actually crashed a piece of a rocket into one of those areas and measured what came off, and it turns out we know for sure that their water is one of the things that is hidden in those poles. We don't know for sure what the source of that is, but volcanism is one of the possibilities.
What is the concept behind permanently shadowed craters? How can that possibly be on the moon?
So unlike the Earth, which is tilted in its orbit, the moon is almost exactly straight up and down. So the deep craters at the poles, actually you can't get sunlight down into the bottoms of those craters. So there are places that haven't seen sunlight for over 1 billion years.
That's absolutely fascinating. In fact, there's a indication from some of the missions that we've had by looking at certain things like escaping neutrons that there may be trapped water underneath the surface. And that's indicated all kinds of different things about the evolution of the moon's poles over time. What can you tell us about that?
Yeah, that's right. It turns out the places that these permanently shadowed regions don't match up perfectly with where we find evidence for volatiles. And if you work it backwards, it turns out that the actual pole of the moon seems to have shifted. And so that it's in a different orientation now than it was a couple billion years ago.
That's another fascinating aspect of the moon. How could that possibly occur? How could the moon have shifted its pole after it starts spinning?
So you've noticed maybe that the moon looks different on one side than the other, right? One side has the side that faces the Earth has all of these volcanic fields, right? It has all of this dark lava that has flowed out onto the moon. And the other side does not. And so the two sides are different. They have different thicknesses in their crust. And they probably weren't always perfectly coordinated with one side towards us and the other. And over time, that has turned out to be the lowest energy position. And so the pole moved in order to get it into the correct position.
Wow, that's unbelievable when you think about it. But those are the kind of things that planetary scientists have to really tease out of the data, is how these planets evolve over time. And it takes billions of years to do so. One of the really fascinating areas on the moon that we have discovered in the space age is on the backside. It's called the South Pole Aitken Basin. What is that, and what can it tell us about the moon's evolution?
So the South Pole Aitken Basin is one of the biggest impacts that we have found in the solar system. It's big enough that it actually probably cut all the way through the crust and down into the mantle of the moon. And probably if it had been even a little bigger, it might have blown the moon apart. And so it gives us an opportunity, a place where we can see deep down into the moon where we can't anywhere else. So we are hoping one day to be able to go and take samples from there and see what those deep rocks look like.
The Earth has got a structure of a core where most of the heavy elements like iron and nickel is, and then the next major area is called the mantle, and then on top of the mantle is the crust. And the mantle, which it also undergoes enormous amount of pressure, really changes the mineralogy and really changes the configuration of the rocks. And we can't get to the mantle, our own mantle, and yet there might be mantle material on the backside of the moon. So from a planetary geologist's point of view, that's really spectacular.
Yeah, it's very exciting.
I recently heard about the discovery of some of these large lava tubes. From my perspective, that's very fascinating. It tells us about, past geology of the moon, but also could be a future home for astronauts. What can you tell us about them?
Yeah, so lava tubes are created, right, when you have lava flowing and the top surface cools, but the lava underneath it continues to flow. And so you end up with basically a tunnel left over where the lava has flowed out. And it turns out, yeah, they are places where we could actually consider putting people, right? They're protected. They're protected from the space environment, which is very harsh and has, you have to worry about everything from radiation to meteorite impacts and things. So if you put your people underground, they are much safer there. And so that's a very exciting thing. But it also tells us about the moon itself and what the lava was like and how it flowed. And so we can learn about the geology of the moon as well.
What do you think that we have yet to learn about the moon? We know everything we need to know?
No, we certainly don't know everything we need to know. We've actually, we've been to a few places on the moon, but it's actually very small. It's like if you were, visiting Earth and you went to, Iowa and, North Dakota and then said you were done. Oh, we've seen the whole planet, right? And you haven't. Like the planet is big and the geology is very varied. We know from remote sensing that there is geology on the moon that we haven't gotten to yet. There are rock types on the moon that didn't exist in the places where we went with Apollo that we haven't yet sampled. So there's still plenty we don't yet understand about the moon.
One of our missions now, the Lunar Reconnaissance Orbiter, is still operating the moon, making spectacular measurements. What additional things is that telling us?
So we've learned a lot. The Lunar Reconnaissance Orbiter has been up there now for many years, and it has been giving us a fantastic record. Some of the coolest things I think it has taught us is about the current things happening on the moon. We can actually see impacts. We have imaged the moon many times now, and we can find new impacts that weren't there the last time we went around. So we know that they're brand new things that just hit the moon. That's pretty exciting to be able to see that the changes on the moon in real time. And we can see down to incredible detail with these cameras. We can actually see down to the level of, we can look at the Apollo landing sites and see the footprints that the astronauts left behind, which is just an amazing ability.
Yeah, some of those images that, we've got posted on the web that people should go to and look at are just spectacular. One of the ones I like are, like Apollo 17, where you can see the huge regions that they walked around and of course they had their neat little rover car, and it's even still on the moon.
Yeah, you can actually see the flags. I like that. Apollo 11, the flag got knocked over, but on many of the other missions, you can actually still see the flags and the shadow that the flags are making on the ground.
Well, it got knocked over because it was too close to the limb.
Land.
Yeah,
Yes.
which was the Lunar Ascent Module.
Yeah.
And the rockets blew it over. Yeah, right.
After that, we learned to put it a little further away.
From Earth, we see the moon, but we only see one side of the moon. No matter where you are on Earth and during the whole month that it takes for it to go around the Earth, we only see one side. And that can be a misnomer. Many people think that the back side of the moon is the dark side of the moon. How can we explain that better?
Yeah, that's an excellent point. Right? The back side of the moon gets the exact same amount of sunlight as the near side of the moon, right? It just, as it's traveling around the Earth, right? It is also seeing the sun just like we have day and night on the Earth. The moon has day and night as well, although their day is 2 weeks long and their night is 2 weeks long as it travels around.
What I really enjoyed looking at the astronauts in the movies when I was young as they walked around the moon is they were bouncing up and down and they were really kicking up the dust. What's that all about?
Yeah, because the moon is smaller than Earth. It has less gravity. It has about 1/6 the gravity of that we have on Earth, so you'd weigh about 1/6 as much. And so even though their suits are actually big and heavy, they still weigh a lot less. And so it's pretty easy to bounce. It is a little tricky to walk, though, it turns out. It takes some time and effort to learn how to get your moon legs and figure out how to walk. And if you watch the astronauts, particularly early in their missions, they're stumbling around a lot. They took a lot of falls. It was not super easy.
Yeah, it was almost like they were straight-legged.
Until they could figure out how to
waddled back and forth
right.
between
Well,
the
the suits didn't help either. The suits don't have a center joint, so you can't bend forward, which made it very difficult to lean over and pick up rocks.
Yeah, the Apollo suits. Yeah, since that time, when the shuttle got going, they redesigned the suits, and then they were much more modular.
Yes.
The Apollo astronauts brought back rocks from the moon and other things like the regolith. And where do we store that? And what are we learning from that? And is that still useful today?
So absolutely. The rocks are mostly kept in Houston. There's a small percentage of them that we keep actually in a separate place in order to make sure that just in case Houston gets some sort of catastrophic loss, whatever, we don't lose all the rocks, but most of them are stored in Houston, and they're stored actually under nitrogen. Most of the rocks have never been exposed to the Earth's atmosphere to keep them clean and free of contamination. But we do actually lend them out to researchers across the country and across the globe. Anybody who has a good idea can apply and ask to have some small bits of rocks to look at. This is actually what I did for my PhD thesis, was look at Apollo samples to try to understand the effects of the space environment on the rocks and soils on the moon. But we use them for all sorts of things. I mean, so my research, that was a while ago now, but there are plenty of people still doing research on those rocks today. In fact, some of the big discoveries we've made about the moon in the last decade have come from those samples. Even though we've had them now for 40 plus years, it turns out we have better equipment now. We have more detailed measurement techniques, and so we're still finding new things. Like, for example, we found out a few years ago, we found that there's water in lunar samples. We thought, for years, because of the violent way that the moon was created, we thought the moon was bone dry, that there was no water left in those rocks. But now that we have the ability to sample at higher precision, we found that, in fact, a lot of the moon rocks still do have water in them.
There was another mission called Chandrayaan. It was launched by the Indian Space Research Organization that NASA had an instrument on. And that instrument did look at the mineralogy and therefore gave us an indication of water on the moon. And it had quite a variation in it. What was that variation all about?
Yeah, that's yet a different kind of water on the moon. So now we've talked about water at the poles, water in the rocks. And then there's this third kind of water that the Chandrayaan, the M-cubed mission, found, which is sort of ephemeral water that shows up on the surface of the rocks. I want to say dew, but that's a terrible way to think of it because it's way less water than you would have on dew. But it's sort of a small amount of water that is created with interactions with the solar wind that sort of sits on the surface of the moon in certain places.
The impacts on the moon are just everywhere. And as you point out, there are still impacts going on today on the moon, and we see that. Well, what does that tell us about the environment around the Earth?
Yeah, for everything that hits the moon, things are hitting the Earth too, as a matter of fact. We have an atmosphere, so small things get sort of filtered out and burn up in our atmosphere. On the moon, everything that comes through hits the surface and does a very small amount of down to things that are microscopic and submicroscopic. But bigger things hit too, and they hit with some frequency, as we've seen from LRO. And so, yeah, those same things are hitting the Earth as well all the time. Fortunately, most of the Earth is ocean, and even of the part that's land, most of it's uninhabited. So we actually don't hear about all of the things that hit, but they are hitting regularly.
Those things that hit the moon, the asteroids and meteoric material that hit the moon, bust things up and produce some of that regolith we talk about. And that's called the gardening process. What do we know about that?
Yeah, so the moon, again, has no atmosphere to protect it, so it's constantly being hit by things, right? And that sort of is what forms the soil and the dirt on the moon, right? As opposed to, on the Earth or Mars, where you have wind and water and other things that are breaking things down. On the moon, it's almost entirely impacts. And so it is just billions and billions of years of impacts over and over again that turn over that soil and make it active.
So the Apollo program brought back some of that soil, that regolith, and we started to look at it. What were some of the surprises with that when we looked at it?
So it turns out most of that soil is glass, right? So every time one of these tiny little things comes in and hits, it melts a very tiny amount of material. And so it turns out 50-60% of lunar soil is actually glass, little tiny shards of glass, which is interesting. Yeah, it is interesting. The astronauts found it actually very difficult to deal with because it's very sharp. They're tiny little shards of glass, and so they stick to everything, and they get caught in your clothes and they get caught in your eyes, and it's not fun stuff to deal with.
In fact, some of the hazards of walking around on the moon would be bringing those shards from your suit back into the habitat, and then eventually breathing that and getting that in the lungs. So.
Yes, absolutely. You have to make sure you engineer ways to prevent that sort of thing from happening.
I'm Jim Green, and I'm here with Sarah Noble. and we're going gaga over the moon. One of the things I ask every one of my guests is what their gravity assist was. And Sarah, what was that thing that happened to you that just propelled you into this field? What was your gravity assist?
So I was always a space nerd. I was into space from the time I was very young. And I absolutely love space. And I headed to college and I started off as an aerospace engineer for real, because it was the only major that had the word space in it. Although it took me about a year to figure out that I was not an engineer. I was not destined to be an engineer. It was not my thing. And I wandered around for a while and I stumbled into geology and I fell in love with geology. And I had fantastic professors at Minnesota who knew I loved space and who steered me into planetary geology, who made sure that there were speakers that came to talk about planetary geology. They made sure that in my petrology class, they got the lunar thin section rocks brought in and made sure that in fact, they told me to go to all the labs. Don't just go to your section, Sarah. Go to all the labs, spend as much time with the moon rocks as you want. And apparently it worked, because here I am still in love with the moon rocks.
That's fantastic. Another thing that you do, Sarah, that I dearly love is your artwork. And you are really quite a talented artist.
Thank you.
How did you get involved in that? And what are the kind of things that you like to do?
So I've, much like space, I have always been in love with art. I actually minored in art as an undergraduate and have tried to find ways to work that into my life ever since. And I am, so inspired by the moon. The moon is a very frequent motif in my work, as are all the planets, just because I think they're beautiful and amazing, and I just want to share that with the world.
Join us next time as we continue our virtual tour of the solar system. I'm Jim Green, and this is your Gravity Assist.